today I thought I'd talk about one of the very peculiar and particular problems associated with semi or fully air-gapped networks, and that's the concept of certificate revocation. Now, first let's talk about how certificates work. A certificate is a type of cryptography. It's used to confirm that you are who you say you are, or that the other end is who it says it is. And you're most familiar with this with HTTPS. You know, somebody's told you, hey, look for the little green padlock in the URL bar when you're going to your bank. And that's done by a third party called a certificate authority. Your bank goes and gets their name signed, and they present a private key, public key pair. And when you go there with your browser, it turns around and talks to that CA, and it's got something in its trust store, and it figures out, yeah, that is who it says it is. And it has this concept of revocation, and that's because people make mistakes. So I've got this private key, and I've kept it squirreled away, and I use it to sign my website, and suddenly, oh no, an unknown miscreant shows up out of nowhere, and they steal my private key, and they sign a page as me. I would be embarrassed, could be worse, could lose money, etc. So what I do is I go and I revoke my certificate when that happens. So how does the revocation work? Well, this is a little bit controversial, and when we're talking about consumers and browsers, the trajectory of travel that they're going in is to reduce the duration of the certificate, so it doesn't matter as much. So when you signed a certificate, it was good for years, and then it was a year, and then it's going to be 3 months, and eventually it's going to be, I think, 47 days. But the concept of revocation is the same. Your browser, which has this trust store, and it has the certificate that is presented from the far end, it has a way to go to a third party and say, hey, this certificate hash is still good, and it can come back and say, no, it's not good, don't trust it. And that can happen for the root, it can happen for the intermediate, it can happen for the leaf certificate, etc. But the key is it's sort of exactly the same as the CA concept, which you use to validate it in the first place. There's a way to check that it's no longer valid. Now, we talked about the direction of travel reducing so that in the consumer browser, your bank case, it's becoming a little bit less important. 47 days, maybe people can get their heads around, oh my God, it's been stolen. I hope they don't use it in the next couple of months. In my opinion, you still need it. But anyway, where it really becomes troublesome is in code signing. And code signing is something you absolutely should do when you run a binary on your machine or a driver that's going to run inside your kernel. It should be signed by the vendor. I am who I say I am, and it's sort of the same as going to your bank. What happens if they've signed it and they lost control of the certificate that they used and somebody else has it and they've signed some malware? That's embarrassing, right? So company A, very proud of their products, and somebody steals their cert, and malicious company B is signing something as if it was company A. It turns out that certificate revocation works exactly the same way here. Your machine, when presented with a new piece of software, which is signed, is going to check, is that signature good? And those signatures are good for a long time. And there's two types here. There's what's called a time-stamping certificate. So the certificate might not be good now, but was it good when you signed it? Because the idea is you're installing an executable, you might have it on a CD-ROM, if you still have one, and you might want to use it 10 years later. So the question is not necessarily only, is the certificate good right now, but at the time it was it signed by somebody who had valid possession? And that means that you need to really worry about that certificate revocation because the time horizon for it is really, really long. So how do you do that? Well, there's two basic protocols. The first is just called the Certificate Revocation List, CRL, and it's embedded in each level of the certificate. The CRL is there. It's an HTTP URL, not HTTPS. And there's a way to fetch that list, and you can parse it yourself. And then there's something called OCSP, or Online Certificate Status Protocol, where you just pass the hash of the cert to something, and it returns yes or no for that one thing. Now, how does that relate back to my first statement about the air gap and the isolated network? Well, isolated networks are not isolated just on the inbound direction, my friend. They're isolated on the way out. So you got a machine inside there, you go to install some software, and you're going to have a bad time. It's going to say, I can't figure this out, and it's just going to hang. It's trying to get to the CRL, to the OCSP, those servers, and can't get there. So it's like, I don't know what to do, so I'll just sit and wait like a petulant child. And as a consequence, You might override it and say, well, I'll just turn off certificate checking, but then you're weakening this core thing. That means a supply chain check or a supply chain hack could get you. So how do you fix that? Well, it turns out we've invented a very novel solution to this. One of the challenges that you run into, in addition to the CRL, is where they are. They're hosted on public CDNs. And that's another phrase for infinite number of host names and IP addresses. So you might have been thinking, well, I'll just allow that one thing outbound through my firewall. Well, two reasons you wouldn't want to do that. First is, now you've got a channel that somebody can get information in and out of your plant, and that allows them to bring up their C2 and connect back home from ransomware, so you don't really want that. But secondly, now that you know it's an infinite number of IPs and host names, suddenly there's no way to do that. You cannot put in a firewall ACL rule to allow the certificate revocation list because it's unbounded. Every cert might have its own, and it's port 80 and yada, yada, yada. So here at Agilicus, we come up with a solution for that. So the way we did it, it's a little bit complicated, but for the top 10 million websites and code signing, we looked at all of the certificate revocation lists that they used, how they were signed, and we scraped all that. And then we make that available as a DNS list, so you've got some way you can redirect that to us. But then it's not just as simple as turning that on or off for all of those, because again, it's an unbounded set, but we have a proxy that sits in the middle, and for all the data that passes in either direction, it confirms that was in turn signed by a valid authority. So what that means is the person asking the question, they can't exfiltrate data because it would have to be signed in a valid format by a third-party CA that's already trusted on your network, and the response can't be used to infiltrate data, same reason. So it's a very novel solution, and it allows you to have that air-gapped isolated network, but still have that little pinhole across so that you can validate signed code inside it. Because I do believe you should be using strong cryptography even on isolated networks. And the best way to have strong cryptography is to have it signed by a third-party CA. Anyway, my name is Don Bowman. My company is Agilicus. You can email us info@agilicus.com if you'd like more information on this. Thank you, and bye-bye.